Data Dashboards with QDM. My name is Ben Reese. I'll be moderating for you today. I have with me Tegu Vivek, who will be our presenter. I'd just like to start with a little bit of with a little introduction and a little bit about DCS. So our agenda today is going to be the brief introduction, and then going into why we want to automate our data collection or our dashboards. Why is this important? And then following that, let's talk about how our data to dashboard process is going to benefit our enterprise. And then Tegu Vivek is going to take us into a live use case demo where we have a sample setup of a company and show you how to delve into the data and how to see dashboards at different levels. We have some time set aside at the end for a question and answer as well. Speaking of that, I'd like to note that on the right-hand side, you can go ahead and submit your questions throughout the entire event. I'll try to answer questions as they come up. Those that I'm not able to answer or that require a little bit more explanation or demonstration, we'll hold off to that question and answer at the very end of the webinar. Now, we'll probably be going about 30 minutes for the webinar today, and then we'll leave about 10 to 15 minutes for the question and answer at the end, so we won't take up too much time this morning. Of course, all of you who have registered will receive a recording of the webinar probably sometime tomorrow afternoon. I'll be able to get it out to you. What's nice, and what I thank you for coming and joining us live, is we really enjoy getting your feedback and getting your questions so we understand what it is that you're interested in and what you'd like to see more of. So those of you who are familiar with DCS know that we have two product suites. We have a product suite for quality data management for handling production, measurement, and metrology. This is our QDM suite of products, which we'll be focusing in on today, one particular application. We also have a suite of dimensional analysis tools, our 3DCS suite of products. Today's presenter, as I mentioned before, is Tegu Vivek. He's our QDM GDM product manager here at DCS. Now, he's been with DCS since the year 2000 and is a Six Sigma Black Belt with an MBA and master's degree in mechanical engineering. Vivek has been instrumental in creating a suite of quality products and services in line with market needs by leveraging the latest technology. Vivek has more than 20 years of hands-on experience in manufacturing quality initiatives in an array of different industries. This time, I'd like to pass the presenter over to Tegu. Hold on one second. All right, want to just show your screen? Perfect.
Let me open the presentation. Seems like that. Okay, just give me 1 second. I'm almost there. Okay.
All right.
Okay.
All right.
I'm going to skip to the slide where Ben left off. First, good afternoon, everybody. First, let me talk by starting the webinar by giving you an overview of the current processes that's in the plants. We're talking about manufacturing companies which are manufacturing multiple products. So when you take any typical manufacturing company, they do one or multiple products. Each products are made for a set of customers, and for each customer, they are supporting multitudes of programs for each of the customers. It could be one, it could be more programs. And these programs in turn are on the shop floor, they are assembled, as products, so there is an assembly process involved. And what feeds the assemblies are the parts and sub-assemblies that are manufactured in the shop floor. So this is a typical manufacturing facilities layout, where the shop floor primarily is engaged in the activity of manufacturing parts and sub-assemblies and assembling them into products. So when you look at, there is an extensive activity of data collection going on at the parts level, and we'll look at what are all the different ways of data being collected on the part and sub-assembly level. We call this shop floor data because primarily the data is directly related to the shop floor activities that are happening in the plant. So when we look at parts, there are different parts and sub-assemblies manufactured across the shop floor. And let's explore a little bit on why we measure these parts, or what are the typical reasons why these parts are measured in manufacturing shop floor. One, for informational attributes. That's more for temperatures, pressure, the environment variables, anything that could affect the quality of the part, and for information only. There are quality monitoring attributes where we monitor where features and parts and different dimensions or different characteristics of the parts are measured to monitor the stability of the process. This is primarily for more of a monitoring activity rather than a quality control activity. Then comes the measurement that are primarily for critical to quality attributes. In any assembly or part or anything that's been manufactured, certain characteristics are deemed to be critical to quality as they affect the assemblability of the product downstream, or those could affect the warranty or any downstream activities even after the part leaves the system, leaves your environment. So the next topic of quality data measurement is for quality problem solving attributes. This is primarily the most common type of data collection that happens in a shop floor, which are primarily designed for local problem solving, root cause analysis, and anything that's happening that seems to prop up as a quality issue on the shop floor. So now let's look at, these are the 4 different ways why reasons why quality data is being collected. Now we're going to look at, for all these parts and assemblies that are made in the shop floor, what are all the different frequency? And the frequency of this data collection also changes depending upon the needs. Some may be done as manual small batches. Some are done on a regular basis, but on a sampling basis, maybe 5 parts a day of the volume of data, volume of parts that are made in the shop floor. Sometimes it could be vision stations and inline inspection devices where every part is measured, or 1 in 10 parts are measured. And it could be handheld devices where things are checked on the shop floor as the parts are manufactured and assembled. So there is a multiple frequency of these data being collected, and also the formats of all these data being collected are different, because the reason being there are different metrology tools are employed in the data collection activities. What that gives rise to is a multitude of formats of data that's been published to the quality engineers and the quality team to analyze and perform their quality activities on. So we're looking at different ways of measuring, different reasons for measuring the data on a shop floor, the different frequency of measuring the data, and also the different formats of measuring the data. All this poses a big complexity when we try to create an overall quality of, or the quality to be able to track the quality metrics in a streamlined way. So let's start at the part level, and we talked about the 4 reasons why we are measuring the part. When we look at the part measurements, we look at a part where there are specifications and dimensions and GD&Ts and different design specifications that are applied to it. And multiple measuring equipments are employed depending upon what we are trying to measure, if it's a profile of a curve, a blade, a different type of measuring equipment is used. If it's a dimensional attributes, then CMMs are being used, and it could be handheld gauges. There are multiple measuring devices operate on this part to collect that data that's required for all these four purposes that we talked about. And once this part is measured, that part pretty much moves or gets moved into a subassembly where that part's consumed or being used in the subassembly. And from the subassembly level, that product moves into a final assembly of the part of that particular part or assembly. Now, on the final assembly, there are multiple objectives and functional characters that are in place. And to make sure that all those functional attributes are satisfied, there's a multiple design and specification that are applied at the product level. So now the quality team is now interested with making sure the quality of all these components and all these functional attributes are satisfied as a part, all the way from a part level to a subassembly level to the product level. And of course, when we talk about keeping track of all this, for any quality engineer, it can cause indigestion. Ben has put an image of showing that this is a complex problem, and this is something that's challenging, especially when you are dealing with a complex assembly or part. So now we're looking at it from a part and a product level. What if now you are in a company where there's multiple products supporting multiple customers, supporting multiple programs and assemblies and all over your shop floor, and multiple different measurement devices are used in the shop floor to track different attributes on each one of these assemblies and parts. This really poses a problem of getting a challenge of streamlining all this data into meaningful information. It's very at the part level, what we are proposing, or our tool is provides a method to take that complex hierarchy that we saw, the architecture that we saw at the shop floor, which looks like a chaos. We try to put some structure to it so we can start at the plant level, report work on the product level, going down to the customer level, into a program level, from programs to sub-assemblies, and sub-assemblies to parts. So creating an architecture of hierarchy, which is more of a top-down approach, all the way from a plant and ending at the part and sub-assemblies, which are typically the shop floor activities. So ability to report on all the part level quality metrics, which is primarily things that are done for small root cause analysis, all the way to creating a quality metric for the company. All those attributes can be measured and automatically stored, pulled into a database, and create dashboards at the part level that satisfy all the needs of the quality engineers on the shop floor. Now, once that is completed, take all that data and provide a method to aggregate this data from each part that contributes to this assembly and create an assembly level dashboard. And from the assembly level dashboards, aggregate the data into program level dashboards across different programs that's made in the shop floor or in your plant. Move that up one more level to a customer level dashboard by able to aggregate all the programs that we are doing for a certain customer and then creating a dashboard for that particular customer. Moving that up to a level of product and all the way up to a plant level dashboard. Keep in mind that the measurements are only done at the part and sub-assembly level in the shop floor for local root causing and problem solving, but we have the ability to take this data and roll them up at multiple levels and creating a very streamlined hierarchy at the software level and not at the shop floor level, even though the shop floor could be doing this activity with multiple sharing. Maybe the same part is being used in multiple programs. the same machines are being used to create multiple lines, or a single line is being used to support 2 or 3 customers. In the shop floor, to gain efficiency of the equipment that we have on the shop floor, the process could be very clustered depending upon the needs. But whereas on the software level, we can create a very clean architecture from plant to product to customer to program and assembly, and report all these disparate data that's collected on the shop floor at different points in the shop floor, and provide a very streamlined dashboard capability at higher levels. So let's take the key to all this is these activities are currently being done at customers, but they are done as special projects, meaning each one of these activities to be able to create a product level dashboard or a part level dashboard or a customer level dashboard means it basically triggers a huge activity string of going and collecting all the parts related to it, putting together in Excel, trying to create a report out of it, and building charts and graphs for each one of them. What we have the ability to do is to automate this entire process. So every time a part is measured, it automatically feeds a part level dashboard. And when the part moves on, whenever the part is being measured, we know how that is going to affect the sub-assembly level, so we can create an assembly level dashboard. And as soon as the part is measured, we also know how the multiple parts that are going into a product are going to affect the part, so we can create a product level dashboard. So just by measuring the part, we were able to create a part level dashboard, a sub-assembly level dashboard, and a product level dashboard. So, and the idea of automating that in the background, and server based, so that at any time a user can get an update on what is my product level dashboard, what's my quality metrics, or my quality metrics at the product level are being met or not. All right, so now we move to the, let's take a sample company called Auto Tier, which, let's take one of the divisions of the company called the brakes division, and assume that we're supporting 4 customers for that brakes division, and for each of these customers, FD, JA, TO, and SA, we are supporting 4 programs, corresponding programs, F1, T3, S2, and J2. And for each of these programs, we're building sub-assemblies, F1BA, TR, T3R, S2R, and J2SA. And for each of these sub-assemblies, there are parts that are made. Sometimes it's just a single part. Sometimes it's an assembly that's going together with a rotor and a caliper. So let's take a simple company setup like this, which a brakes division of this, and let's really take it to a corporate level where this Auto Tier company contains 3 divisions. It's got the brakes division, which we just saw in the previous slide. It's got an accessories division, which is supporting 3 customers, CR, SA, and GR, and an engines division, which is supporting 2 customers, TO and SA. When you are looking at a company structure like this with multiple plants and supporting multiple customers, but parts are only measured at the shop floor level, how do I get a report for a customer level? How do we get a report for a caliper level? As a quality engineer manager or a plant manager or a corporate level manager, you might be wondering, what is my pass-fail rate of all my SA caliper assemblies that are happening? Even though there are multiple parts that are made for that assembly, what is my overall capability or my pass-fail criteria for the caliper assembly? These are some of the quality metrics, and it could be every company have their own unique quality metrics that you are targeting and trying to achieve. Another quality metric could be work, or another information that you might want could be, what's my overall capability of my accessories division? We're making multiple parts, multiple programs, supporting multiple programs for multiple customers. What's my overall capability of my accessories division? Could be, what's the percentage in spec of all my critical to quality features on my engine division? How are we supporting all my critical to quality features on my engine division? You can also, once the data is collected, we can also slice and dice the data in a different angle and say which manufacturing machine in the plant produces the or is the cause for the highest instance of failure. So we can look at the data running through multiple machines and create a dashboard from the machine point of view so that you get an idea of which machine is causing is contributing to the highest number of failures. Thereby you can assign your maintenance team and your activities towards fixing that particular machine or the machine line. So ability to use just the part data, part inspection data, but to extract the machine information is also a possibility with the dashboarding capability that we offer. So with this company setup, let's now try to jump in and look at a real software where we have set up the same dashboard for a certain company. Let's look at that and a live demo on the software and how we can bring all this, a company with so much complexity supporting multiple customers, multiple programs, multiple division product types, how can we quickly and easily create a dashboard level and allow a streamlined quality approach for your organization. So I'm going to jump out of the PowerPoint and go into the software.
Why don't you bring that up for us?
Okay.
You don't need me as much today to go with
Okay.
other presentations.
Now we're going to go into the
There it is.
software. So I'm going to go to the quality data management website. The QDM is a QDM Web is a quality data management web system which allows you to so let me log in with the username 23 password. So we sign in and we go into the management reports. So what the system allows you, it's a web-based system, so it can be accessed anywhere in your corporate network once this is set up. It's purely server-based. There's no software running on your interface other than Internet Explorer, so it's purely a web-based system that you can access it anywhere. When you go into the system, you could start at the dashboard level where we're looking at a company dashboard with the company information grouped by plants. So I can get dashboards based on the plants and how they are doing. I can get dashboards based off of customers and how are we supporting each one of these customers, and also go down and look at program by program and look at how we're supporting each one of the programs. So let me take a few minutes just to kind of walk through each one of these dashboard setups. I'm going to start with the company level dashboard. So when I click on that, the system creates a dashboard at the company level and rolls up all the data that's measured and critical to quality in all my plans and for all the programs and all the customers, and creates an overall capability of the entire company where we are as far as the capability and the critical points, critical to quality pass-fail criteria. And we can look at the data in a more of a, this is kind of a snapshot report and when it was last updated. We can also, if you want to delve deeper and look at a history of this, how we've been doing and what is the difference from the last time, last time when this was run. It could be periodic, it could be daily, it could be weekly. How much are we up or down since the last dashboard report or metric whenever we were scheduled to run. We can also look at it in a more detailed way, so we can kind of see a history for the last 10 days for each one of the programs that's attributing, each one of the programs that is contributing to the that value. So let me kind of, so these are all the different programs that's contributing to the dashboard and giving you an overall capability of all the different, there are 1,260 measurement critical to quality features that are tracked for the AD, for the accessories division, connecting rod, C4 program. Similarly, for each one of the programs, we are seeing this total 9,330 features that are tracked as far as critical to quality for the entire organization, and how each one is faring as far as capability and percentage okay, which is basically the pass-fail criteria. And this statistics can be set up to any statistics that your company wants to track. It could be CP or CPK, PP or PPK, it could be range, Six Sigma, variation, any type of statistics that we can calculate. We will be able to set the dashboard up so that according to that you can gauge your quality metrics. So now we're looking at it at the company level, and down below you see the entire list of each one of the components that's contributing to that dashboard. For the GR customer, how are we supporting the G1 program? For the SA customer, we're supporting 2 programs, and how we're supporting those 2 programs individually. Now let me go back to the dashboard again, where now I'd like to see how is the brakes division doing and what's my capability just on my brakes division, everything that the brakes division is doing. And it kind of rolls up everything that all the components that belongs to the brakes division, and provides an overall capability for the brakes division and showing individual capability for each one of these components. So an example here, I would like to click on the TO, the SA S2. Now I can look at what are the components of the brakes division, what are the programs that we are supporting for the SA S2 program. SA is the customer name, and what is the percentage and how we're doing as far as the percentage OK, CP, and CPK on the critical to quality items. Now I'd like to drill down a little bit further and go in and see for this subsystem, what is my, what part are we making and what is their capability. And in this particular case, there's only one part that's feeding to this, so there is only one item here. Now I'll be able to look at the rotor CMM value and take the last 8 or 10 samples that are measured. I would like to get a generator report for the last 10 samples for that, and I would like to generate a complete report for that, a quality engineering report for that particular part for the last 10 samples. It provides me a graphical report which is pre-authored and updated to the system with all those critical to quality features and how they are faring for the last 10 samples. This provides you an intuitive way from going all the way from the dashboard level, which is the company or the division level, all the way to a single component that's made in your organization. If I would like to know further about this particular feature, I can click on that, and it'll provide me with a more detailed trend chart with statistics and a trend chart of that particular feature that's measured on my shop floor, where I can go and click on one of the items to understand what is the sample number, what's my JSN number for that, so we know which part was contributing to that value. So ability to go all the way from the dashboard level to a single part measured at a single date and time on your shop floor is what the system provides. When we take this data that's collected disparate formats and disparate ways and disparate frequencies in your organization and trying to put them into a neat and into a nice top-down approach, and the system allows you to navigate to this in a top-down approach, very intuitively, going from just focusing on the problem and providing you an overall dashboard. Now let me look at how we're supporting a certain customer. Let's take the customer called the TO and look at how for this customer TO, overall capability that we are delivering to this customer is 100% on all the critical to quality and 97.92% on the capability and 95.9884% on the CPK. So we're very high on capability and percentage okay for this particular how we're supporting this customer. And this is something, this is constantly being updated as data is flowing in the back end as parts are measured in the shop floor. So now you are at this level. Now it's telling me for the TO customer, there are two plans in our company which are supporting the engines division and the brakes division, both of them supporting a program called T3. So how is the engine division supporting the T3? I can click on that, and it's telling me we have we have one of the components we are making for the engine from the engine division for the customer TO, and these are the capability ratings for that particular customer for that particular subsystem. Now I can click on that, and it'll take me to a level which is deeper than that, which is the inspection program that's running on that particular, or the shop floor data that's feeding to get that subsystem report, and I can click on that to get a detailed report. And this time again I'll do the last, this time maybe I'll do the last 20 data and create a report for the hub flange. System says I've selected the data. It gives you a quick summary of how we're doing for that hub flange, and I'm going to click on the generate report button, so it generates a live report for that hub flange. And you see in a graphical format, in a problem-solving way, where how the critical to quality features are measured and reported for the last 20 samples that are made on the shop floor. So provides you an overall view of the entire system from any for your entire organization on a web-based interface. Let me go to that last level of dashboard, and we'll take any questions. We're doing okay with time.
Doing just fine.
Let me pick a program level dashboard. So let me pick a program called F1 program. And now F1 program is running a little bit low on the percentage on the critical to quality features. There are some things that are failing, which are critical to quality. We'd like to explore further. So I'm looking at the dashboard level, which is only all the F1 program is coming from brakes division, and we are supporting this customer FD on this. So I can click on that data source name, and it tells me that's all coming from a BA assembly, which is a brake assembly, which is F1 BA, and these are the capability and the percentage okay for that. Still, I'm not getting to the bottom line of why it is 98.38. So I'm clicking on that. So now it is telling me that that particular BA assembly, there are two data from the shop floor. One is a rotor and a caliper. So the brake assembly contains a rotor and a caliper. The rotor is doing fine because that's all 100% on capability and percentage okay for all the critical components. But the caliper seems to have a little bit of problem, and it's saying it's failing some of the critical to quality features. So let's investigate further. I click on the caliper CMM, and now I will maybe move the date to today so I can get all the data. I see 50 samples. I'm going to take the last 20 samples and select that data, so I can see the last, how it's doing in the last. I could do for a certain date or for a certain sequence set, and I am going to create a report for the 20 samples, and it runs the report and tells me how this is the brake caliper, and it's showing me that the edge points are okay. But looking at my chart, I do see some failed points on the width between the calipers. So that's what's contributing to the issue that we were seeing on the dashboard. So now we can send the corresponding team or task to go and look into this particular issue and resolve that issue. So once that issue is resolved, and when we go, and then the data is collected and uploaded in the shop floor, it would automatically upload the management reports for the F1 program. And in that particular case, they will be back up to 100%. So provides you a way to somehow eliminate all the chaos in your quality in your shop floor and create a clean top-down drill-down mechanism, and also constantly keep you updated with your quality metrics at any time for at different levels, whatever your key, however you want to look at it, whether it's a company level, plant level, customer level, or at program level. It's a fully automated system, and it's fully configurable by user-friendly forms, and the system runs totally hands-off. So with that, I will
all right,
end the thing. And
well, I appreciate that, Tagu. Thank you very much. We do have just a couple quick questions. Good. So the first one, well, let's go back here. The first one was the report that you showed. How was that report formatted? How did you get that formatting set up within the dashboard? Since we're talking about dashboards and then you're pulling reports out, where did those come from?
Reports are generated, so we have a tool called QDM Analyst, which will allow you to author any of these reports. So let me quickly generate a report, and I will show you the capability. I'll show you that. I'm going to go use the same method that we followed. I'm going to go to the caliper, move and select all the 50 data, and create a report. So this report, so the question is, what allows you to create this report? We have a standalone tool which is 3D CAD based, where I can load in a CAD model and load in any data and author very quickly a report of this format. Maybe I will very quickly show you one report format. I'm going to have to close all of this. Let me open the tool so you can look at it. Let me open a break type report. So what this provides you is a 3D interface to create a report the way you want it, set up the charts the way you want the charts to be laid out, and also choose what is critical to your quality. Maybe you are measuring from all the charts that are being measured. You can choose the ones that are critical to your quality and then assign them to this report. So thereby, you're really creating a critical to quality template, because in your shop floor, you might be measuring multiple different data sets for multiple reasons. All of them don't have to be rolled up into a quality dashboard. We only want to isolate the ones which are, identify the ones which are going to affect your overall quality, and this interface allows you to do that in a user-friendly way and publish that as a template to the system. Once it's published as a template to the system can reuse that same template and apply the new data that's coming from the shop floor and update all your statistics, and in turn update the multiple higher levels of dashboards automatically. So there's an authoring piece which will allow you to customize your critical to quality features in a user-friendly way and set it up onto our system.
Great. I actually think that carries over into our next question. So, so my company has a different set of metrics, as we don't make cars or aircraft. Is there a preset set of series of metrics that I have to use?
No, the metric could be anything, and it all boils down to how we set up our template, and whatever we require the template to populate, the system will automatically update the template to. In this particular case, we have chosen the capability to be the CP and CPK to be the metric. If you would like to choose any other metric, then the same tool allows you to identify what is critical to quality of all the different criteria that you would like to use. It could be mean, PP, PPK, Six Sigma, range, CP, CPK. It could be spec limit. Any one of the statistics can be used to set it up, and based on what you set up, the system will roll up and create your dashboards.
Now, let's see. There are a number of different clicks to generate the report. Every time I want to generate a report, do I have to go through that same process?
If you need to only go to a certain, right now we're using a top-down approach of we don't know where the problem is, so we're starting at the company level and finding out where the issues are. But you could directly go to a navigation data. If you know what part you want it to do, you could directly go to, I would like to see the auto tire. I'm in charge for the brakes division, and I would like to see the report that we are doing for the SA. I'd like to see the S2 program data, means brakes division SA S2. I'd like to see a subsystem of R and rotor CMM. But if this is something that you could navigate to your every part that's made on your corporation, you could navigate and see the report. Or if this is something that you would be doing on a daily basis, you can add this to your favorites, and from this point onwards that you can see your favorites, and when you go to the navigation page, you open up your favorites and click on, you can always keep track of how your favorites are doing as far as your CP and CPK at the part level, or you can click on the link and it would auto-populate the entire page and get it ready for your reporting. So if you are in charge for a certain set of parts or certain set of sub-assemblies of products, you can set up favorites so you can always keep going back to them and eliminate all these button clicking and navigation.
Yep. Good. All right. Now, you mentioned before determining which machine has the largest failure rate. How would you do that?
There are multiple ways we can do that. One option is in the management reports. If we know we can also group them not only by the division, by area. The area code could be what machine this was made on. Another method to do that would be when we are authoring the templates, we can pick all the features that are made on machine 1 and create a template for that, and that template will automatically update the statistics for all the parts that are made on that machine. So thereby, when we set up our roll-ups and look at them at the dashboard level, for each one of the parts we have created a machine-based template. Instead of a dimension-based template, we can create a machine-based template, and those statistics get rolled up all the way to the dashboard, allowing you to see the machine-based values and not dimension-based values.
So if I understand that correctly, on those reports you saw, instead of calling out all the different measurement points, it'd be calling out the statistics of each machine?
It'll be calling out the points, but the points would only contain the machine. Let's say in this particular part, these holes are all done by machine number 1, a drilling machine, and these points, the center hole is done by a different machine. Then what we would do is we would separate them into 2 templates, one for the center hole machine. So this would be a template for machine 1, and we create a template for machine 2, and thereby when we are rolling up the statistics, we have already done the grouping based off of machine, but parts are only going to be measured. Machine is never measured. Parts and features are only going to be measured, but we have the ability to take the part measurement and group them based off of the machine and roll up the statistics all the way to the top.
All right. Okay. So the next one, this all looks good, but how complicated is it to implement this kind of dashboard setup?
It's a good question. This is pretty much an off-the-shelf system, meaning everything can be configured just by interfaces. So let me show you an interface how we set this up, so that that'll give you an idea of. First, we so what we have done is, let's say for that one engine gear 2 program, what we have done is just filling out this form, telling the system to take the last 30 samples. Every time 30 new samples are done, take the last 30 samples, use a corresponding template based on your quality metric that you have generated, and run that either on a trigger basis or every time new sample comes, different ways that you can run this thing, because we're really setting up an automation, and we're telling the system to update the statistics. So what this does is, so I can change this to, so every time 30 new samples come into the system, take this particular template, run the 30 new sample data into the template, create the statistics, and update my dashboard. So this is just one form that I need to fill out, and the rest is all automated.
Well, all right. Okay. One more. So, let's see if I can. So you showed the template authoring tool.
Yes.
Right. And that is a separate tool from the dashboard rollup. This the web-based.
Yes, the template authoring tool is a standalone tool which allows you to load in any data or author any type of template, because it contains a very extensive tool set to create any type of templates, any type of authoring template that you want, and it's fully customizable. It's just point and click, drag and drop, and it's a true 3D environment. So if you have 3D CAD parts, then it just makes it that much more easier to create your template, because all your points are automatically linked to the 3D as you're creating a report. So let me quickly close this template and open another template for maybe the engine. So that's for another rotor type. So let me open and close this and open another one. It's totally a different template for a different part. Okay, good. That's the same. Let me close this and open another one. Okay, let me go here. We'll go to, okay, let me do a hub flange template. So that's a hub flange template. Let me open another one, close. So it's purely point and click, drag and drop type of template. So let me go to accessories. Let me do a sprocket template, 200 millimeter sprocket template, 3D GDZ file. Okay, there you go. So I can change the chart type to what different chart types we want, what different methods we want to set it up. It could be run chart, it could be comparator chart, it could be any type of chart types, and we can author these just by pointing and clicking. So let me say you would like to see this in a comparator chart mode. So now you have this data all pointing in a comparator chart mode, and I'll even move that to a new page. So now it allows me to create my template. I'm just showing you the ease of use of creating a template and the look and feel of what you wanted to show and how you want to set up a template. So very quickly, I've set up a new template for this particular part.
So okay, so that starts to answer the next question. But how long does it take to create one of these template reports?
Okay. The templates can be done very easily. So let me close this data, and I'll show you a wizard interface on how easily we can create a template.
While you're doing that, there's just another follow-up to it real quick. So when you create the templates, do you have to create new ones regularly each time you're measuring, or do you just create them once?
The templates are only created once. Every time data is measured for that template, it automatically refreshes it with the new data. So template creation activity is a one-time activity.
So you do that all up front, and then then it's all automated, and you have to worry about it.
Based on your inspection program, you create one template, and then so I'm going to select data data set. Okay, maybe a sprocket. I'm going to import some data.
Now, if you don't have CAD data,
then you can use 2D images and create your templates.
Okay.
So do that. Open. Use the right opening data. So it's just two inputs that I'm giving you, a CAD input and a data input, and I'm going to set all my chart types to be like a tabular chart. I'd like to merge my data, sort the data. I don't know how many charts I can put on a page, so I'm going to automatically let the system sort the data and ergonomically place the charts, and the system automatically loaded the data and created the template. So it took less than 30 seconds for me to create an entire template, and then you could always use the tools to update the template, or if you are all ready, if that's all you wanted to do, then you just have to do File Save as Web, and it gets published to the web interface.
So it took you longer to explain what the options were than to actually make the report, the template. Okay, so I can see you could probably make a lot of most of these templates in, I mean, a single day. Get this thing up and running very quickly.
And it can be automatic. Doesn't have to happen one time. As you're making new parts, you can always keep adding to the system. So it's a very scalable system, because today you might be supporting 2 customers. Tomorrow the customer base might increase. The system can constantly keep be scaled to your needs.
Right. So that means if you set it up early with just 2 customers, and you get 3 more customers later on, it's not a big deal to add them in and increase or decrease your data sets. All right. Well, that puts us at about 5.2. Oh wait, let's see, we got one more coming in. So does it have email notifications?
We do for each one of these auto publishes. We do have an email notification. So every time when we set up an auto publish, we can let the system, when we are running any report, we can tell the system to go into advanced parameters, and based on any characteristics, based on, let's say, capability, if that particular item fails, show me all my red data. Now, when we update the statistics, whoever the contact person who set up that, or to a group who set this up, will be emailed if there is any failures on this part when it ran based on the capability.
All right, one more question. Will it allow suppliers to see the data collected at the assembly plant?
Yes. So the only limitation is the network access. This is a purely website and web environment, so they can create they can access the data. The system's got a very extensive user setup, so you can take each user and give them only access to see. Let's say if it's a brakes division engineer, the brakes division engineer can be given permission only to see these 4 data sources. So that way, when that person logs in, or it could be a supplier, that when that person logs in, they're only presented with the data that they need to see, so they can have access to it, and you can granularly control what data they can see and what data they cannot see.
So you could group your different users and give each one access to different kinds of dashboards based on their responsibilities, right? So if I've got 4 suppliers, and I want each one to be able to see their particular data, I can set it up so each one of those different suppliers, when they log in, they see a different dashboard specific to their.
They will only see what they have given permission.
And then my managers, I want them to be able to see everything, so I can have them come in, and then their starting point will be the highest top-down.
So when we go to the user setup info, this particular case, I took the auto tier customer, and even though I have so many data sources in our system, I only provided for this auto tier user only these 8 data sources which belongs to auto tier. So when this person logs in, they can only see the auto tier customers and the parts and the plans. Each user is individually controlled. So I'm logged in as A tier, which is an auto tier user. So I'm only seeing my auto tier data.
So real quick on that particular regard, does the supplier need to have a QDM software?
The supplier doesn't have to have a QDM software. All they need is an access to your environment on the web interface. You will be updating the temp. They will only be submitting data, and they can see what is the effect on the dash. They can see the reports for the parts for which they are submitting the data using a web interface. They don't need any software installed in their environment.
And when you say data, they can. I mean, you're talking just the outputs from their CMM machine or from their metrology or inspection equipment, or even an Excel spreadsheet with their information.
Whatever data they are creating, they can, as long as if they are submitting the data to this environment through FTP or email or any method, and that gets pulled into the system, we can provide ability to do this. We have a tool called Data Grabber, which is written to it's a universal translator writer for almost all the data that's out there that's collected on the shop floor. We have a translator that's already available. If not, you can create a translator so that any data coming from all these metrology equipment can be processed into a centralized standard relational database, which lends itself to be able to do, lends the system to be able to do dashboards and everything from that point on. So all the variations of the shop floor data collection is streamlined and normalized when it gets into the system.
Excellent. So the short answer, of course, was no, they can access your system. They just have to supply you with the data to put into it. The supplier would.
And you have the ability to control what data they are allowed to see.
Fantastic. Fantastic. Well, that puts us right on the hour. I think we've gotten to most of the questions. The remaining ones we can answer afterwards by email. If you have any additional questions, please feel free to email in. You can email us over at sales@3dcs.com, or you can email me at breese at, see if I can get this all the way down to, went through a lot of stuff today. And there we go. Just so you guys have access to the email address, phone number, and you can always go on the web and find out more at 3dcs.com/QDM. And there's a Contact Us button in the upper right-hand corner. Feel free to contact us if you have specific questions or would like to see a live demo. And like I mentioned before, I'll be emailing out the recording to this presentation along with the presentation itself. And you can reply to that email if you have questions at that time or are looking for additional material. We'd be happy to answer any questions you have, and we'd be more than happy to schedule a live demonstration for you. So thank you, everyone, for joining us this morning. We really appreciate your time and your questions. And please look forward to seeing our next newsletter and our next webinar for the month of November. Thank you, and have a great day.
Thank you.